Hello class, this is just a follow-up video on calculating the mean and variance and standard deviation, because as we saw from these last two, these two were rather difficult to calculate and it took quite a long time. So what I'm going to be showing you here actually is we can adapt what we've learned from discrete probability to calculate the expected value or the mean and the variance and subsequently the standard deviation. We do this by considering the relative frequency as the probability, and we can then use these two formula. The sum of the score times the probability for the expected value or the mean, mu, and the variance is x squared times the probability minus mu squared. So let's get to doing this quick example. So first we need the relative frequency or probability of each score. We do that by considering its frequency, 5, divided by the total of scores. So 5 out of 61, 7 out of 61, 12 out of 61, and so on. As you can probably tell, the probability of all of this should add up to 1. Now, just merely taking the score and multiplying it by its relative frequency or probability. So for this one, this will be 20 times 5 over 61. This one here would be 21 times 7 out of 51. So 20 times 7 out of 61. And the next one would be 22 times 12 out of 61. So we get 1.6393. I'm doing this to 4 decimal places. 2.2951, 4.3279, and so on. Then we take all of those and then we add them. So taking the sum of this row here, this will give us the expected value or the relative, or the mean. So 222.8361, which if we compare it to what we had before, is actually the same. I'm just rounding it to 4 decimal places. Following the same procedure for the variance, we now need to take the x squared times the probability. So this will be, I don't know why I deleted it, 20 squared times 5 out of 61, 21 squared times 7 out of 61, 22 squared times 12 out of 61. Just to clarify what I did, 20 squared times its probability, 21 squared times its probability, and so on. Calculating all of those, we get 32.7869, 50.6066, and 95.2131. We repeat that process for everything. I've already done it beforehand. Then we take the sum of all of these numbers. And following the formula for the variance, we take that sum, 523.69346, minus 22.8361 squared. You can fast forward this little typing part here. 523.69346 minus 22.8361 squared gives us 2.2951. 0.20596, and taking the square roots of that gives us our standard deviation. One 0.485259, which if we compare to what we had, 1.4964, 1.485, so it's not too far away. Oh, sorry, that's using the sample. This one here, 1.485259, 1.484. So yeah, it's not too far away from its original value. And obviously we'd have more error in this one because I only took it to 4 decimal places. So I hope that gave you a sigh of relief that it's a lot quicker than what it normally would be. So hope to see you in the next video. Best of luck.